Hi everyone. In continuation of deadlock, today we are going to see about deadlock avoidance. Deadlock avoidance is the second method of handling of deadlock. We have already seen deadlock prevention in previous session. In deadlock avoidance, let us see what are the scenarios and how we can avoid the occurrence of deadlock in a system. In this, it requires the system must have some additional prior informations which is available to prevent the system from entering into a deadlock state and avoiding the occurrence of deadlock. The simple and most required for each process declaring is it must hold maximum number of resources of each type which might be needed by the processes while executing in that system. And second one is that the deadlock avoidance algorithm dynamically examines the resource allocation state to ensure that there is never occurrence of a circular wait condition will get initiated in that system. And the resource allocation state is defined by the number of available and allocated resources and the maximum demand of that process. Let us see what is a safe state and unsafe state. A safe state is nothing but a state where deadlock can't get occurred in that system. When a process requests a resource and the system must decide whether it can be allocated to the system in a safe manner. That is, after allocating that resource to the process, will the system remain in a safe state? System is in safe state if there exists an safe sequence of all the process in the system, such as the resource can still request for satisfying the currently available resource which was held by the processes in that system. That is, if a process Pi needs an resource and which is not currently available, then the process which is the resource which is getting allocated for that process priorly must get finished first. When Pj is finished, the process Pi can obtain the needed resource and execute and after execution it can return the allocated resource and the Pi get terminated. When Pi terminates, the next process which is in the queue can obtain the resource and after request it will get allocated. After utilization it will release the resource and it will terminate, and this process goes on. In such a way, the single resource is getting utilized by n number of process in an cyclic order based on the queue. In such a state, there will not be an occurrence of deadlock. This is known as an safe state. In this, a system is in safe state. Let us come to a conclusion that there is no occurrence of deadlock. If a system is unsafe, then there is a possibility of deadlock. We can't assure if the system is unsafe, surely there will be a deadlock. That is not a scenario. There will be a possibility of scenario is the only conclusion we can from an unsafe state system. And deadlock avoidance must ensure the system will never enter into an unsafe state. If a system is always in a safe state, we can assure that the system is deadlock free. So, the deadlock avoidance must ensure the system will never get enter into an unsafe state. A state is safe if the system can allocate resources to each process to its maximum need in any order and avoid the occurrence of deadlock, which we have seen in the previous example of allocation of Pi, Pj with the same resources and so on. It is formally said as a system is in safe state only if there exists a safe sequence. Safe sequence is nothing but the execution sequence of that process for all those resources. Here it is. This is the pictorial representation. When the system is in safe state, there is no possibility of deadlock. When the system is in unsafe state, there is a possibility of occurrence of deadlock. Okay.